Lesson 6-1, Operations on Functions. So by the time we're done with this lesson, we should be able to find the sum, difference, product, quotient, and a composition of functions. Okay, so to start with are definitions of operations on functions. So basically we are doing exactly what the name says. So we're going to be adding, subtracting, multiplying, dividing, and then the new one that we probably don't recognize is a composition of functions. So all of these definitions are written in function notation. So again, remember that means that this first piece is the name of the function, and then this is the variable in the function. And we can split these up to say f of x plus g of x, or f of x minus g of x. Okay. Now again, when we are doing this, we are going to be given an equation. So we're going to replace the name of the equation in our function notation with the equation itself, and then simplifying as much as we can. Now the only new one here is going to be this composition. So a composition, when we look at this, this is read as g of f of x. And then this is another way to think of it. So again, g of f of x. So a composition is telling us to substitute the f of x equation into all the variables in the g of x equation. And then again, we're going to simplify as much as we can. And for the division one, remember we're not allowed to divide by 0. So for this one, we do need to state the restriction, so what x can't be if we end up with 0. And that will partially be taken care of when we do domain and range for these functions as well. All right, so we're just going to do a bunch of examples. Okay, so again, it's telling us to let f of x equal 3x plus 1, g of x equals x squared minus 2, h of x equals x squared plus 7x plus 12. So we're going to perform each function operation and then indicate any restrictions in the domain or range. So actually, even before we get started on this, let's figure out the domain and range of each of those equations. So for this equation, since it's linear, the domain for this is going to be all real numbers. Okay. Same thing for a quadratic equation. No matter what that quadratic equation is, the domain of it has to be all real numbers. And then it does say the range, but for this problem, we really only care about the domain. So we only are going to state restrictions on the domain. All right, so again, problem 1, we're doing f of x minus g of x. So I'm going to replace f of x with its equation, so 3x plus 1, and then minus, and I'm going to use a parenthesis since we're subtracting, and then we'll substitute in the g of x equation. So that will be x squared minus 2, and then we just simplify as much as possible. So we would distribute the negative in, so we have 3x plus 1 minus x squared plus 2. And then we're going to write it in standard form and then say what the domain is. So standard form, we'll have a negative x squared, and then plus 3x, and then positive 1 plus 2 is a positive 3. And again, we have a quadratic equation, so the domain for this has to be all real numbers. So this would be our final simplified answer. So next one, this one is telling us to add the g and h equations together. So again, we're just going to write our g of x equation, so x squared minus 2 plus, and since we're adding without multiplying in a number, we don't need parentheses. So we will have x squared plus 7x plus 12, and then we're combining like terms and stating our domain. So x squared plus x squared is 2x squared, and then we'll have a 7x, and negative 2 plus 12 is 10. And again, since we have a quadratic equation, the domain for that will be all real numbers. All right, next one is telling us to multiply our f and g equations together. Now again, you have to remember that this is in function notation, so it's not asking you to multiply x in at the end. So again, this is the name of our function, this is the variable in the function, so don't confuse that for multiplication. So again, we're taking the f equation times the g equation, so 3x plus 1, And then our g of x equation is x squared minus 2. Okay, so again, we're going to FOIL. So 3x times x squared will be 3x cubed. And then x squared times x will be x squared. And we also have, let's see, 3x times negative 2, so minus 6x. And then 1 times negative 2 is minus 2. So this is already in standard form. And from the previous chapter, if we think about our end behavior, we have a cubic equation. So we know that it's going to start and end in 2 different spots. So that means that our x values go on forever. So our range for this is going to be all real numbers. And that would be our final simplified answer. All right, next one, we are doing division. So we have g of x over f of x. So this will be x squared minus 2 divided by f of x, so 3x plus 1. Now remember, for fractions, we're not allowed to divide by 0. So this time for our domain, we have to figure out what we can't substitute in for x. So to do that, we take whatever the denominator is, so 3x plus 1. We're going to set that equal to 0, and we're going to solve that. So we would subtract the 1, and then divide by 3, which is going to give us a negative 1/3. So that means if I substitute in negative 1/3 to the x in the denominator, this will simplify to be 0, which isn't allowed, because we're not allowed to divide by 0 in math. So the domain for this one is going to be x can't be, so it can be anything it wants except negative 1/3. Okay, so this is going to be the final answer for that problem. All right, next one we have an open circle. So that is telling us to do a composition. So this really means f of g of x. So I'm going to actually substitute the g of x equation into the x in the f of x equation. So we're going to take this x squared minus 2. So again, another way to kind of think of this, it's asking us to do f of x squared minus 2. So we're going to take this entire equation and we're going to replace the x in the f equation. So then this will be 3 times x squared minus 2, and then plus 1. And then now we just simplify. So we're going to distribute. So 3x squared minus 6 plus 1. And then we would combine like terms. So 3x squared minus 5. And again, we have a quadratic, so the domain for this is going to be all real numbers. And that's going to be our final simplified answer. All right, the next problem, we're doing subtraction. And notice how this time we actually have a number in place of x. So this is not only telling us to subtract our f and h equations, but also to replace the x's with 2. So when we're done with this problem, we're going to have a number. All right, so again, we're doing f minus h. So what I'm going to do is I'm going to substitute the 2 in at the same time. So here's my f equation. So I'm going to replace the x with 2. So 3 times 2 plus 1 minus, and we're subtracting. So again, I'm going to use parentheses. And then our h equation is x squared plus 7x plus 12. So at the same time that I'm subtracting, I'm also going to substitute the 2 in for all the x's. So we have 2 squared plus 7 times 2 plus 12. And then now we're just going to simplify that as much as possible. So 3 times 2 is 6 plus 1 minus, and again, we have to simplify everything on the inside. So 2 squared will be 4. 7 times 2 is 14, and then plus 12. So again, following order of operations, 6 plus 1 will be 7 minus, and then we would have 4 plus 14, so that's 18. And then if we take 18 plus 12, that will give us 30. Okay, so now we have 7 minus 30, which is going to be a negative 23. And there's no restrictions because we ended up with a number. So negative 23 would just be our answer for that problem. All right, so next one, we have f of x over h of x. So again, we would have 3x plus 1 over, and then x squared plus 7x plus 12. So because we're dealing with a quadratic equation for this one, to figure out what our domain can't be, so again, x can't be, we have to figure out what we would substitute in to get 0. So because we have a quadratic trinomial, that means that we have to factor that to be able to figure that out. So looking at that, I'm going to use a different colored pen here. Two numbers that multiply to be 12, add to be 7, would be x plus 3, and then x plus 4. So if we set each of those groups equal to 0, and then solve, we would have x equals negative 3, and then x equals negative 4. So if I substituted in either of those numbers, I would end up with 0 in the denominator, which again is just, it's not allowed. So that means that our domain would be x can't be negative 3 or negative 4. And this would be my final answer with restrictions for that problem. All right, 8, we are back to a composition. So again, this is asking us to put the f of x equation into the h equation. So we're doing h of f of x. So our f of x equation is 3x plus 1. So again, I'm going to replace all the x's, and we have 2 this time, so 2 x's. So this will be 3x plus 1 squared plus 7 times the quantity of 3x plus 1 and plus 12. So now we just have to simplify that. Now we do need to be a little bit careful because on this term we can't just square each piece. So that's asking us to FOIL. So we're really doing 3x plus 1 times itself. Okay. And then so here if I just distribute right away, that will give us 21x plus 7 plus 12. So again, if we FOIL, 3x times 3x will be 9x squared. And then 3x times 1 will be 3x. 1 times 3x is 3x. And 1 times 1 is 1. So again, if we can combine the 7 and 12, so now we have plus 21x plus 19. And if we just combine all of our like terms, we will have 9x squared. And then this will be a 6x plus 21x will be 28x. And 1 plus 19 is 20. And then our domain, since we're dealing with a quadratic, is all real numbers. So no restrictions for that one. So that would be our final simplified answer. All right, so this equation, again, we're back to doing a composition. So again, since we have a number here instead of the x, we also need to replace all the x's and simplify. So I think what I'm going to do first is substitute the f of x equation into the g of x equation and then replace my x's. Okay. So again, I'm going to just start by doing g of f of x, and then I'm going to substitute in that negative 3. Okay. So again, our f of x equation is 3x plus 1, so I'm going to substitute that into this spot. Okay, so that means that we will have 3x plus 1 quantity squared, and then minus 2. So now what I'm going to do is I'm just going to replace that x with negative 3. So we will have 3 times negative 3 plus 1 quantity squared minus 2. So that will be negative 9 plus 1. So let's see, negative 9 plus 1 will be negative 8 squared minus 2. So negative 8 squared, negative is on the inside, is going to be a positive 64. And then if we minus 2, our final answer will be 62. And that will conclude section 1.